Alright, so my computer doesn't allow me to record my voice, so instead I'm going to use my phone. Alright, regardless. This is a tutorial on, or no, more like an explanation on how memory works and what is basically memory for a computer process. Now, what I've made here, it's just a simple bit of code. This is to convert what I'm gonna define that I'm gonna talk about today, which is a vector. Okay, this vector is an array. An array basically holds things. So it's holding these three integers right here. So we have int a, which is 5, int b equals 8, int c equals 10. Now, this code basically allows me to convert uint pointer. It's a Unicode integer pointer, and it allows me to turn it into an address that I can actually display in the console. Now, if you don't understand, here's the thing. If I try to console output the vector, whoops. As you see, it will not let me do it at all. So what I do here is this code right here, find the address. This converts a vector into a uint pointer. So that's what we want, and then that uint pointer right here, we basically can console output it. So what is memory now? Every process has something called memory. It is allocated when the process starts up. Now, this right here, this is allocated. Everything with an A will be allocated within the process memory. That's allocated. This is allocated. This is allocated. This is allocated. Okay. Wait, actually, that's not. So everything with a /a, it's allocated memory. Now, what happens is, if we start this process, okay, in the Windows debugger, this is what we'll get. Oh, what did I do wrong? Oh, sorry. Okay, wait, let me turn this off. Alright, so we're gonna start up the process again. So, okay, so this right here is the memory address, okay? This is the memory address of the final address. And the final address is the base, which is right here, uint pointer base, and the vectors I defined. So, this is just, yeah, it's pretty straightforward. This is just the base to hold the vectors as a memory address, so I can console output it, so it's easier for me. But this is the address, all right. This is the value of the vector. So this is what the current value is inside the vector, which is 23. If we add it 5, 8, and 10 equals 23. Okay. Now this, I have this code here again. So this is where vectors come in handy. Okay, so vectors can hold things, not just memory. It can hold anything you want. And the good thing about vectors is like it's just like an array, but instead that if anything changes, any values changes within the vector, it automatically updates the vector as whatever the value is now. So as you see, the value is 23. Okay, so if we copy this dynamic memory block, okay, and we go into cheat engine, right? If I hook it back up to the process, okay, yeah, that's right. So now we're back in the process. We'll add this address manually, okay? So we got 23. So now it matches up. This is basically the vector. Now, if we, wait, first of all, the next line of code, okay? So we're at here right now. We're right here. This is our line of code right now. We're right here. Once I type something and press enter, it's going to display the new value of final address, which is still the same thing. Now, I'm going to change this value. Let's say 99, alright? The value is 99. Okay, so let's see what the value is going to be once we enter. As you can see, the value is now changed to 99. First, it was 23. Now it's back to 99. So that's basically vectors. Vectors can hold memory, all kinds of things, but the main focus on here is, oh, let me bring it back up. The main focus here is the memory block, the memory addresses that we see. So, right here, this is what we want. Now, this right here, this is the hex value for the memory block that we just pulled. So this equals to my vector. Alright, so this is that. Okay, this block here represents that. Now the problem is, since when you start up a process, it allocates memory dynamically. Okay, so when the memory gets allocated, it's only there until the process ends. Now the reason for that is because we're working in user mode, and the difference between user mode and kernel mode, it does not have any runtime support, so you have to do things on your own. For this, since we're running in user mode, this is all user mode code. Our constructors are basically doing the job for us, so it's creating the memory for us. So if we load this up again, it creates the memory block for us. Now you notice that the value is the same, but now the address is different. So at first we had this, but now this is this. Why does it say it is this now? And this is also equal to my vector. So what is that? Basically, this here, when we opened the process the first time, it gave us this memory block. That's what the constructors made. They made that the address block. Then when we ended the process, the constructors basically deleted this memory block, deleted it from existence. All right. So now the whole process is gone. This doesn't exist anymore. All right. Now we start it up again. Now this is our new memory block. They create a new memory block to hold this value. Like I said, memory is dynamic. However, if you want to get the static address where you can literally, it's going to be a fixed address. I'm going to do an example like whatever, blah, 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 blah. Say this is the complete static address. So no matter what, every time I load it up, the constructors will create a dynamic. So this is the static address. Okay. And every time it loads up another program, this is the static address. Okay, the constructors create its own separate dynamic memory block. Oh wait, you cannot have this in here. Now this is the dynamic address. All right. Now the link between the dynamic and static is that this dynamic here, it points to this static address. All right, but the static address isn't what's being displayed on something like Cheat Engine. See, we got the dynamic address. All right. So what I mean by that is, let me start up this process again. Let me open up Cheat Engine. Now if we start with the process, we go into our exe. So now we're in here, okay? If we look at the value 23, we're going to get all of these addresses that points to the values that we looked for. If we look for 23, this is the address blocks that holds the value 23, okay? Now, as you see, we have this value right here. This is the new dynamic address, okay? We also have it right here too. So we definitely know that this is the address for my vector. Now, to make a static pointer, what you would do is you would do this. You would pointer scan for an address, okay? And I'm not going to go into detail, but it basically just gives you the offsets so you can point to the static address that the constructors did on their own. So you basically don't allocate memory unless you put it in your code. But for kernel mode, you have to do it on your own because you have to call the constructors to do the job for you, unlike in user mode that it does it for you automatically. And if you have any handles, say I open up a handle, equals, let's just do create file, random.txt. Fuck, I forgot the command. So fuck it. Anyways, let's say we create a handle. All right. Let's just say the fucking process is running. Okay, the handle was up. If we do not close this handle, right? If we don't close this handle, if we don't add this code here, and this handle is left running in kernel mode, the memory that leaks out of handle handle. Let's say if there's memory here. So let's see. Let's just say this is the memory chain right here. If there is memory that comes from this handle and we don't close it in kernel mode, this memory here, this memory block will leak. Okay, this memory block will leak into your system, and it will not delete itself because you have your process running in kernel mode. Now for user mode, it doesn't matter. You don't even need to close the handle. As long as you close the process completely, everything closes out. The constructors get rid of all the work. So that's user mode, basically. Memory for user mode. Now for coding, you don't have to use Cheat Engine. You could use this right here. You can, if you're going external, this is necessary in order to read the memory. So you would read the process memory that from the process you are trying to get the memory from. Then when you're ready to write your value, you just do write process memory. Simple as that. Okay. Now, as you see that the vector does hold values that can change over time. So what if we let's say, what if you changed the value for one of the ints over here? So we're gonna start up this again. Actually, wait. Let's do this. See out the value, the address block for A. Yeah, the address block for A equals. Oh, no. Address value. Okay, yeah, that's it. So let's run the process. Let's open up Cheat Engine. So this is the memory block for integer A. Now if we start up this process again, we hook on to the, no, we don't want that. Now if we go and we're looking for A, right? So if we go look for 5, now we gotta look for this value, 008C2048. Now we see it right here. Okay, now this is the value. Now remember, the vector, this vector is holding the values of A, B, and C combined. So what happens if we change the value for one of the ints? Now this is what's going to happen. So we're going to change this to, let's say, 988, whatever. Alright? Now let's see the value now. Why is it 23? How come it changed the first time? Well, that's because the vector, this right here, the cout, this isn't even updating itself yet. First, it needs to be updated. Now, how do you update it is right here. We're going to update it right now. As you see that I did change the value for A, but in the vector didn't even pick that up. Now the reason for that is because this is a memory block for the int A, but this has already been modified. So what we gotta do is we have to take this, move this down here, and right now I'm gonna stop the code from running. We're gonna do char. We're gonna do console input C. Now this is before the vector even begins, so we know that vector equals 23, right? We know that it equals to 23. So let's start it back up. Oh yeah, also this memory is being allocated. Oh wait. Okay. So we know this is the memory block now. So we're going to look up for the value 5. We're going to look up again. Oh, wait, we're not in the process. We're going to look at the value 5, okay? We're going to look for... Yeah, we found it. So this is an A. We can call this integer A. So now let's change this value to 86. Let's move on with the process. As we can see, the value has changed from 23 to 104. Now that's how you know that the vector is actually holding the values correctly. And if we were to edit the vector now, we'll take this address, 104. So now if we edit the vector, 0039 F9DO. So this is the vector. Now let's edit the vector to, let's say 754, okay, whatever. Now what is the new value? 754. Now that is exactly how memory works, guys. So this is memory address. This is the memory address right here. This is everything that's being allocated in our process. Now if we can go through multiple numbers, it's going to allocate everything. It allocates everything that deals with the process. Some of these memory allocations really don't matter. It's basically allocated by the compiler itself, which is why some of these addresses we don't allocate on our own. Like I tell you, the constructors are doing this work for us. We're not doing no work. So yeah, simple memory tutorial. Hope that wasn't too long, or if you didn't understand anything. But I'm just trying to make YouTube videos now, and maybe coding is something cool, I guess. Maybe not, but anything else I might think of, I'll upload a video on it, and yep, I'm out.